Good morning, everyone. Let us discuss about decision tree learning. So this is a method for approximating discrete value target functions. Let us get into the details. The decision tree learning is a method for approximating discrete value target functions in which the learned function is represented by a decision tree. Okay. So here whatever solution we are obtaining, that we are expressing as a decision tree. And not only a decision tree, it can also be represented as a set of if-then rules to improve the human readability. These algorithms can be applied to all the inductive inference algorithms. Some applications based on these inductive inference algorithms are to learn tasks such as diagnosing medical cases and assessing the credit risk of a loan application and equipment malfunctions by their causes. Not only this, all problems with the following characteristics can be solved with the help of decision tree learning. Okay, so where instances are represented by attribute value pairs. So that means for each attribute, you are having a disjoint possible value. So like that, you have an attribute and you have a set of associated values for the attribute as well. And then the target function has a discrete output value. So usually this is suitable for Boolean classification. The example that we will be working is also a Boolean classification one, but this can be easily extended to learning functions with more than two possible output values. It need not be a Boolean value, but it can be a multi-valued as well. Then disjunctive disjunctions may be required. So that means the decision tree, the final outcome of the decision tree can be expressed as a disjunction. Then the training data might contain errors. The decision tree is robust to noise, so it allows the errors. Though it has some errors also, it works correctly. And these error can be either the error in the training examples that we are taking or in the attribute values of these examples. Okay, so the error could be either of the one or it could be both also, but still the decision tree is robust to errors. And the training data might contain some missing attribute values as well. Okay, so if the value is absent also, our decision tree learning is going to work appropriately. Let's see the decision tree representation. Let us see one example. So here you can see a tree structure. You are very familiar with the tree structure, right? And here you can see the nodes. So the nodes are represented in the rectangle or the square. Okay. So it is each node. What it indicates is test of some attribute of the instance, and the paths whatever you have, that is the each branch. It is the possible value for this particular attribute. For example, if you take Outlook, this is an attribute. Okay, so this is having three possible branches: sunny, overcast, and rain. So these are nothing but the possible values for the attribute Outlook. Similarly, if you take humidity, its possible values are high and normal. Then finally coming to the leaf. So here you can see the leaf nodes. Always the leaf nodes are the ones which are there at the last level of the tree. So here the leaf nodes are labeled as either an S or a no. So it is saying some decision of the target variable, some classification it is giving. Okay. So this is how the decision tree is represented. Now, the overall decision tree can be represented as a disjunction of conjunctions of the constraints on the attribute values of the instance, and each path from the tree to leaf. So that is what we have done. So we have expressed this tree as disjunction of conjunctions. And now if you take a particular path, so that particular path can be represented as conjunction of attribute tests. And when you express the overall tree, you will just apply the disjunction on these conjunctions. Okay, so let us just see the example. So here the first path, if you see, What is the first path? Only the SS we are considering, that gives us the output. Means that particular path is going to lead to a solution. So here the first path that we have is outlook is equals to Sunny, the value of the attribute. The attribute here we have is outlook. Its value is Sunny. And in this path, I have one more attribute. So let us connect it with some conjunction, and humidity is equals to normal. Okay, one path is done. Conjunction of attribute tests are over. Then coming to the disjunction of these conditions, then that means I have to move on to the next path. So in the next path, what I have, outlook is equals to overcast. So here you can see the next attribute is outlook, and its possible value is overcast. And this again is connected with a disjunction, that is an R, and then move on to the next path. So in the next path, what do we have? Outlook is equals to rain. This is one constraint. And we also have one more constraint, that is wind is equals to V. So let us connect these two with an AND. Okay. So this is the meaning of disjunction of conjunctions. So the overall decision tree is represented as disjunction of conjunctions, that is R of AND expressions. So this is how we represent our decision tree. So there are popular decision tree algorithms. So among them, the first one is ID3. This is represented as iterative dichotomizer tree. Okay, so this is given by Ross Quinlan in the year 1986. This algorithm creates a multi-way tree. Just now, whatever tree we have seen, that is the output of this ID3 algorithm itself. Okay, this we will be solving shortly. And this is purely working with categorical features of the attributes. And it works on the information gain. So the next algorithm is C4.5. So this is the next successor of ID3. But this algorithm it works dynamically. But the thing is, it not only works with the categorical data, but it also works with discrete values also. Suppose if you have continuous values also, it will be broken up into discrete value pairs, and it works on that. And this C4.5 converts the trained tree, that is the decision tree, into set of if-then rules as well. Not only the tree, this can also generate set of if-then rules. Then we have C5.0. This is most efficient compared to C4.5, but this needs a proprietary license. So this is not a free resource. It needs a proprietary license, but it uses very less memory, and it builds smaller rule sets also. It is more accurate, but the only thing is it needs a license. Then we have CART, stands for classification and regression trees. Okay, so this is applicable for the regression problems. So here the numerical target variables are required, and it constructs binary trees using the information gain again. But the thing is, here it works on continuous values. So in the regression, always we work with continuous values, whereas in classification, we work with discrete values. So the basic algorithm ID3 is a classification algorithm. It works based on discrete values. The target value is always a discrete valued attribute. So this is the basic information about decision trees. In the next, we will be seeing one example for this ID3 algorithm. Since it is the basic classification algorithm, we are working with ID3. If you have any queries or any suggestions related to this, please do post in the chat box.